Hello. My name is Mohand. I am working with Jeff on his film Sing to Me, and I'm gonna show you my workflow on tracking camera using Buju and importing it into Unreal. So let's get started. So the first step consists in setting up the units in 3ds Max, both system units and display units. I always set it to centimeters. After that, I import the scene. In my case, it's an FBX scene. I let everything as it is. So this is the scene. Now I verify that everything is in there and there are no problems. For the materials and lighting, I prefer to rework them directly inside Unreal. At this stage, I don't touch or move anything, and mostly never change the scale of the scene manually because it will lead to bad camera movements later. I save my scene. I will use it later to reposition the camera. Then I export it with Datasmith. I can ignore this message. It says that Datasmith did some things automatically for us. Now the first part of the process is done, and now we're going to deep into Unreal. Now I'm going to prepare the Unreal scene. First of all, I create a blank project. I remove all unnecessary things, generally the plane. I then import the Datasmith file. I set Datasmith to automatically set for us the resolution of the objects between 256 for the small ones and 2048 for the bigger ones. Generally, I don't import the lighting. I create it directly inside Unreal. Let's wait for Unreal to finish the loading of the shaders. Once the compilation is finished, I immediately start working the lighting. Generally, I create a natural lighting, but of course it depends on the lighting of the video. To set a natural light, I have 3 openings in the 2nd floor and the main door of the garage. To let the external light penetrate inside the garage, I move the door up. Before I start putting the lights, I first tweak a bit the rendering engine to have a more precise result. For that, I set the static lighting level to 0.5. And the number of indirect lighting bounces to 30. In fact, the more the bounces of light, the more the photons will hit the surfaces of the scene and you'll get a brighter result. Once it's done, I then put a light mass importance volume. This object must take in the entire scene, so it will concentrate the computation inside that volume. In a way, I ask Unreal to ignore what is outside that volume. I start now creating the lighting. I use bright planes which simulates the light coming from the sky. Once the planes created, I select them all and give them a new material which I create. The material is pretty simple. It is a total white material with emissive color set to 1. The more the emissive constant is high, the more brighter the object will be. I then go to the lighting settings of the planes. In Lightmap, I check use emissive as static lighting, so Unreal will consider them as lights. I hit build with preview quality. So now the rendering is finished. That will let us see how the material interacts with our lighting. I always add a post-process volume to adjust the exposure. I set it to infinite, then I change the exposure values. From there, I'll start working the materials. As you can see, I already have a problem with Decole's material. It must be an alpha problem. In fact, I noticed that it was a bug that inverts the texture alpha. I just reassign the same alpha to the same channel and the problem is gone. So for this tutorial, I'll make 2 examples of objects to which I'll redo the material, because the video may take an eternity to end if I had to do it for all the objects. I start with the metal material, then I'll go for the floor one. In this scene, all the materials are standard materials, no reflection nor opacity. What I do for all the materials is to give them some reflection, because every object is reflective at some point. So by doing just that, it increases the realism of the scene. So for the floor, I remove everything except the texture. I add a desaturation node. I multiply it by a constant to control the intensity, then I assign it to metallic and specular. I do the same thing for the roughness. Then I change the values until I get a satisfying result. I create a couple of sphere reflection so that the reflection will be more visible. I then go to my post-process volume and I increase the reflections quality. Here is a bit too much. Now I like the result, so I go for the next one. Like I did for the floor, I do the same for the metallic material with different values. immediately you get the reflective aspect of the metal and the imperfections also. So, by the same way, I work each material until I get a realistic scene with a good quality. Now the last step, the rendering. I start by verifying the light map of the objects. You must know that the light map determines the quality of the lighting received by an object. The more the light map of an object is bigger, the more the rendering quality of that object is better. And, of course, obviously the build time also rises. Keep in mind that the size of the light map must be proportional to its surface. For example, for that object, it represents not just the floor of the upper part, but also the ceiling of the bottom part. That means that its visible surface is very big, so the light map needs to be. Here we see that Unreal has already set the light map resolution to 2048, which is enough. That was set automatically when I have imported the datasmith file in the beginning of the video. Unreal has analyzed the surfaces of the objects and gave them the optimal size within the range I fixed. In my case, 256 for the small objects and 2048 for big ones. I hit build lighting in production quality this time, then when it's finished, I'll move on to tracking. Now the tracking part. I use Buju, which is, as you'll see, pretty easy to use. I start by importing the sequence. The first step consists of masking the moving objects in the sequence. In our case, the actor is the only one who moves. I create a mask which I animate by moving it as I go through the timeline. This will let Buju ignore the moving parts of the sequence, which can lead to wrong tracking. As you can see now, I have masked the actor. After that, I click on Track Features, which will find the key information that will allow Buju to recreate the camera movement. I let everything as it is except for the sensitivity, which I increase. Buju has finished gathering the necessary information for the camera movement evaluation. I just have to launch the camera solving to create the camera. I always check this checkbox, which give a smoother movement of the camera. Now Buju has created a camera which we can see here. The camera is moving, as you can see. Now I have to test whether the camera is correct or not. For that I add the test object which I position in the scene in the 3D view. Then I come back to the 2D view and adjust the size of the test object and its position. Then I play the sequence. As you can see, the object is well positioned and you feel that the object is a part of the real environment and is behind the actor. That proves that the tracking is successful and I can export the camera to 3ds Max. But before that, I have to match the orientation of Buju world with orientation in 3ds Max. In fact, 3ds Max Z-axis is directed upwards, whereas in Buju it is the Y-axis which is directed upwards. And by importing the camera as it is in 3ds Max, I'll get a camera directed downwards instead of straight ahead. That's why I need to perform some transformations to reorient the camera in Buju to be correctly oriented in 3ds Max after the import. For that, I go to Scene Geometry. I need to realign the background on the grid plane, so I select the points which represents the green wall. I click on Add Coordinate from Hint. Then I hit Connect. Then I choose the XZ axis. The scene in 3ds Max is oriented like this. Buju is oriented like this. What I have just done is reorient the camera relative to the orientation that I have in 3ds Max. The reorientation of the scene is the first important point to deal with before I export. The second important point to deal with, which can lead to problems, is the scale unit. In Buju, 1 unit represents 1 meter. In 3ds Max, I set the units to be 1 centimeter. If I import the camera as it is, Max will convert 1 unit of Buju into 1 unit of Max. So what measures 1 meter in Buju will measure 1 centimeter in Max, and so in Unreal. So in a way, a movement of a half meter to the right in Buju will be a movement of a half centimeter in Max or Unreal. That will give me a barely noticeable movement in Max and Unreal. That's why I always multiply the scale factor by 100. Let's try to import into Max and see the result. I open the script, then I execute it by pressing Ctrl E. You notice that the camera is upside down. So I have to tweak it inside Buju and never do it inside Max. Here I have the Z-axis directed upwards. That's how the camera has to be. I need to give it a 180-degree rotation around the Y-axis. I come back to Buju. I open the scene geometry. I click on rotation 180 on Y, then on update. I export again the camera. I reopen the script, I execute it again. You see that the camera is well oriented this time. Notice that as regards the rotation, it is absolutely imperative that it be done in Buju. Whereas for the translation, you can translate the camera as you want. So if you want the camera to be directed, for example, this way or another, you have to do it inside Buju. Like that. And by exporting this camera directed this way, you'll see that it's also directed the same way inside Max. I can test by moving it. You see that the camera animation is still good, but never rotate the camera inside Max, always do it inside Buju. So I position my camera as I want. I do the positioning visually as regards the position of the actor in the sequence. I export the camera in FBX format. I let everything as it is. I confirm. I come back to Unreal. At this stage, if you followed exactly what I showed you, you'll get a correct result. So I create a level sequence. I give it a name. I click on the camera to create a camera. I click on the actor. I choose import. I select the FBX camera that I exported. I disable those things, I don't need them. I confirm. I'll change the exposure so that I can see better. You see that the camera is well positioned as it is in 3ds Max. I adjust the length of the sequence. The footage provided is in 24 images per second, so I have to choose 24 images per second here too. I also adjust the length of the clip. Now we can render. I save. The render has finished. We are going to After Effects now. In After Effects, I import the background sequence and the video sequence. By default, After Effects imports the image sequence with a 30 fps format. So I need to change this to 24. I create a new composition. I insert in it the video and the background. I readjust the video size as the background size is smaller than the video one. Now, as I did inside Buju, when I masked the moving actor, I do the same here, but instead of masking the actor, I show only him and mask everything else. The green that exceeds inside the mask will be removed in the keying step. I then animate it while moving the timeline. I remove the green using Primate Keyer. I click on select background. I click then on the green part. Then I use clean background to improve the keying. For that preview, you see that the movement of the camera of the background is the same as the movement of the camera of the actor. If you consider all the remarks that I made and that you followed step by step what I showed you, nothing could prevent you from carrying out your tracking. I hope this tutorial helped you to see more clearly. Of course, there are other ways to do it, but in this video I showed you mine. It was Mohand, Tinedghar from Algeria. I hope you learned a lot of things. Take care of you and work hard. Bye.